from this, make sure you know the number of waves, long versus short. Make sure you know where they're best diagnosed. And know their movement. The primary thing you need to know, movement-wise with the two, they always move from west to east, and short waves will always move faster than the long waves. The diagnose, which level you want to diagnose them at, the movement, and the number of waves. Let's see, I've already gone through temperature advection stuff, that stuff again, that again. Jet streak influence. Again, you should all be able to identify jet streaks now, given the 500 or 300 bar map. Convergence and divergence. You should be able to identify where you have a convergent jet streak versus a divergent jet streak. Where do you find convergent jet streaks? West.
Oh, because the air comes together, right?
Where's your convergent jet streak?
To the left.
Two.
2. Where's your divergent jet streak?
1 and 3.
1 and 3.
That should be a question on the test.
It probably will be.
Just like that?
Similar to that.
Perfect.
You can red marker?
Everybody got that? You know where to find that divergent and convergent jet streaks? 3 and 1.
This is rising.
That's where your rising motion is. So if you're given weather map and you've got jet streaks here, and you see another one out here, and I tell you where is the convergent jet streak, which one are you going to point out?
2.
2. Everybody got that?
Got it.
Remember that. That's number 2.
Number 2, just remember 2.
Got it.
2 is convergent.
Know the quadrants of the jet streak and the vertical motions associated with them?
Do we have to identify them in the map?
Yes. You will have to do that.
Can we,
Yes.
can we like go over the identification?
It's just where your core speeds are.
Can we go over any already?
I'll pull up the map once we get through this,
Yes,
and we
yes.
can identify them. So make sure you know the names, and make sure you know where you've got rising versus sinking motion.
It is.
All right?
I need one of them.
Except it's backwards. It's everything.
Summary, again, all the same stuff. Don't worry about conveyor belts, comma clouds, and where are those? And then vorticity. Know the definition of vorticity. The other 4 types: relative or local, Earth's absolute and potential. Be able to describe what each one is. What's relative vorticity?
It's the apparent spin created by the Coriolis force.
Coriolis plays a factor in it. What actually is relative vorticity?
Conditions we're observing on the surface.
Where?
friction comes into play?
It doesn't have anything to do with friction. What is vorticity? What is the definition of vorticity?
The spinning of your parcel.
Spinning of the air parcel. So relative would just be the spin associated with a given air parcel by itself, not taking into account any other factors. What is the Earth's vorticity?
The spinning that takes into place, taking for account the Coriolis force.
Earth's vorticity basically is Coriolis force.
Okay.
So it's really just Earth's spin. Because it's spinning, it has its own vorticity associated with it. Absolute vorticity is just adding the vorticity of your air parcel to the vorticity of the Earth. Potential vorticity is just the absolute vorticity. So local vorticity, so your local parcel spin plus your spin, and it's looking at it over a given depth in the atmosphere. Why is potential vorticity important? Why is that depth factor important?
Because it allows you to determine the behavior of your parcel, if it's going to create like thunderstorms or not.
More than that. Why is depth important? Comes into play more when you're talking about convection. So if you have a parcel that's spinning, it's at this depth, and you look at the forecast and suddenly it's over this depth, what's going to happen?
You know that it narrowed, therefore the spinning can increase. Right?
Exactly. You know that your spin is going to increase because you've lengthened the column, you've stretched it out, therefore your parcel is going to spin faster. Right? Everybody understand all four of these, what they mean now. Relative, just the spin of the parcel. Earth's, it's just Coriolis parameter of the spin of the Earth. Absolute, a combination of those two. Potential, combination of those two over a given depth. Got it?
Yeah.
Sources of vorticity. And you kind of already know this stuff. Curvature vorticity comes into play with ridges and troughs. Shear vorticity is more in a horizontal plane. You have winds moving faster, lower than higher, creating a spin this way instead of a spin this way. Don't worry about those last two, but you should know this. So as vorticity decreases, that means that your area is increasing, so you're going into divergent area. And as vorticity increases, your area decreases, so you're going into an area of convergence. How does that make sense?
Isn't like when it becomes divergence, isn't it negative? And when it becomes conversion, isn't it positive? In the sense of vorticity, like positive vorticity, negative vorticity.
We'll get to that in a second. Think of this conceptually.
Does it relate to that drawing right there with the high and lows?
It does kind of relate to that. It's more related to this.
Okay.
How come as vorticity decreases, your area increases?
Because there's less spinning of the parcel, more space for spread.
Physically, what's happening? What's causing it to spread out?
It's slowing down of the parcel, right?
Not necessarily the slowing down of the parcel.
It's in a area of convergence or divergence. Area of convergence.
It's in the wind level slower than the divergent area.
Let's say you have a trough. What's my next line of the trough going to look like?
The opposite way around.
So let me ask the question again. How physically do you relate that to this?
On the right side,
Two trough lines.
get closer, you converge,
here's your parcel, spinning. What happens to your parcel when it's down here? Shrunk it out.
Goes faster. Vorticity
Vorticity is
increases.
increasing, your area is decreasing. Vorticity is increasing. Isn't that what happens when you're going from a high to a low?
Basically, when it's coming out through divergence, it increases, goes in the area, decreases, going into convergence, then the opposite thing happens for divergence. The area, the vorticity decreases, but the area increases.
Yes. Something along those lines. I think you have the general idea. Remember, you have a parcel, generally at the top of a high. That's where your parcel area is going to be biggest. As you go from your high down to your low, your parcel size is going to shrink in size because the winds are going to get faster and faster. So your parcel is going to spin more and more. As you come out of the base of the trough, the area of your parcel is going to start spreading out. So you're going to start spinning it down. As you come out of the base of the trough, the parcel gets bigger. What do you have?
Divergence.
Divergence. See how you're putting all of this together now?
Mhm.
You have divergence back here.